Are, welcome, welcome, welcome. Today, we are not talking about my neighbor Sharmaji, but about something just as interesting from the world of computers, variables. So, what is this fancy word, variable? Think of it like the dabbas, the tiffin boxes that your mother packs for you. Each dabba holds something different, right? One has dal, one has rice, another has those delicious aloo parathas. In the world of coding, a variable is exactly like that dabba. It's a container where we store information. This information could be anything: a name, a number, or even a whole sentence. We give each container a name so we can find it later, just like you know which dabba has the gulab jamun. Now, you might ask, Kapil Bhai, why do we even need these dabbas? Why can't we just leave everything out in the open? Well, imagine your kitchen without any containers. Spices everywhere, flour on the floor, sugar mixing with salt. What a mess! It would be total chaos, a disaster bigger than when my bua tries to use a smartphone. Variables help us organize our code. They keep everything neat and tidy. When we need a piece of information, we don't have to search the whole kitchen. We just call the name of our dabba, our variable, and poof. The information is right there, ready for us to use. It makes our life as programmers much, much easier. Let's think about my show. We have so many things to remember. We have Sidhuji's Shayaris. We have Guti's introduction. We have the celebrity guest's name. Each of these is a piece of information. We can store them in variables. For example, we can have a variable called and put Shah Rukh Khan inside it. Then, whenever I need to mention his name, I just use, if tomorrow Akshay Kumar comes, we just change the value inside that same dabba to Akshay Kumar. This way, our script is flexible and easy to manage, preventing any on-stage blunders. It's all about keeping things organized so the show can go on smoothly. So, in simple words, variables are named storage locations for data. They are the fundamental building blocks of any program, just like good jokes are the building blocks of my show. Without them, our code would be a confusing, jumbled mess. But here's the twist. In JavaScript, there are 3 different ways to create these containers, these dabbas. They are called and. Each one has its own personality, its own rules, just like the different characters on my show. Understanding their differences is key to becoming a great programmer and avoiding a lot of headaches later on. So grab your chai and let's dive into this comedy of code. Let's start with the oldest member of the family, the Dadaji of variables. This was the original way to declare a variable in JavaScript, used for many, many years. Think of like a general-purpose reusable shopping bag from your local Kirana store. You can put anything in it, take things out, put something else in, and even have another bag with the exact same name. It's very flexible, maybe a little too flexible, like a politician's promises before an election. This flexibility can sometimes lead to confusion, which is why the newer methods, and are, were introduced later on. But first, let's understand how this old-timer works. Imagine you are planning a party. You make a list of supplies. You write on a slate. Now everyone knows we have samosas. But then, your friend comes and says, Are Kapil, let's get kachoris instead. No problem. With, you can just erase samosas and write kachoris. You can reassign the value. Even more, you could accidentally declare it again on the same slate. Now things are getting confusing. This is a key feature of you can redeclare and reassign it as many times as you want within its scope. Now let's talk about scope, which is a fancy word for area of influence. The scope of is like my voice on the show. It reaches the entire stage, the function. This is called function scope. If I declare a inside a function, it's known everywhere within that function. However, it has a strange habit called hoisting. It's like Sidhuji shouting Thokotali before I've even finished the joke. The declaration of the variable is hoisted or moved to the top of its scope, but its value is not. So, if you try to use the variable before you've written it, you won't get an error, you'll just get undefined. It's like asking for the samosas before they've been made. You know they are coming, but you have nothing in your hand yet. This behavior can cause some unexpected results, especially for beginners. It's like telling a joke where the punchline comes first. It just doesn't work well. For example, if you have a small block of code, like a statement, and you declare it inside it, that variable doesn't stay inside the block. It leaks out and is available to the entire function. This can lead to bugs that are hard to find, like trying to find who ate the last piece of cake at a party. Because of these quirks, while it's important to know for understanding older code, modern JavaScript developers usually prefer to use its younger, more disciplined siblings. And after the unpredictable drama of JavaScript decided it was time for some new talent, some fresh faces. So, in 2015, and made their grand entry. Think of as a modern, transparent Tupperware container. You can see what's inside, you can change the contents. Maybe you replace yesterday's sabzi with today's biryani, but you wouldn't buy another container and give it the exact same label for the same shelf. It brings some much-needed discipline, allows you to reassign the value of a variable, but you cannot redeclare it in the same scope. This prevents the kind of confusion we saw with, let's use a real-life example. Imagine you are tracking the score in a cricket match. The score changes with every ball, right? So, it's a variable we can use for this. We start with, after a boundary, we update it. This is perfectly fine. We are reassigning the value. However, if you try to declare it again in the same area, like JavaScript will throw an error. It's like the umpire saying, out. You can't have two scoreboards with the same name. It's against the rules. This rule helps keep our code clean and predictable. Now let's meet the strictest character on the stage. C. The name itself says constant. Think of as something permanent, like your Aadhaar card number or your date of birth. Once it's set, it's set. You cannot change it. It's like getting a tattoo of your first love's name. You better be sure because changing it is going to be very difficult and painful. When you declare a variable with e, you must give it a value immediately, and you can neither reassign a new value to it, nor redeclare it in the same scope. It's a one-time deal. So, when would you use? You use it for values that you know will never change throughout your program. For example, the value of pi, 3.14159, is always the same. So we would write, or think about the number of states in India. We can set. We don't expect this number to change while our program is running. Using makes our intentions clear to anyone reading the code. This value is a constant and should not be modified. It's a great way to prevent accidental changes and make your code more robust and secure, like a fixed deposit in a bank. So now we have our three contestants on the stage. The old-timer, the flexible, and the strict. How do we decide who wins the trophy? The main difference lies in their rules about scope, hoisting, and reassignment. Has function scope, meaning it's known throughout the entire function, and it gets hoisted. And Khan, on the other hand, are the new kids on the block with block scope. This means they are only accessible within the block of code, the curly braces, where they are defined. This is like having a private conversation in a room versus shouting in a crowded hall. Block scope is much safer and prevents variables from leaking out and causing unintended side effects. Let's quickly summarize their personalities in a table, like a menu card at a restaurant, so you can order exactly what you need. Feature scope function. Scope, block, scope, block, scope. Redeclare, yes, no, no. Reassign, yes, yes, no. Hoisting, hoisted, with hoisted, but not initialized. Hoisted, but not initialized. Best for legacy code values that need to change, values that never change. This table is your cheat sheet. It clearly shows that, and are more predictable and safer to use. They don't have the weird hoisting behavior of that can lead to bugs. While they are also hoisted, they are not initialized, creating something called a temporal dead zone. This is a fancy term that simply means you cannot access the variable before its declaration is encountered in the code. If you try, you'll get a clear error. which is much better than getting a silent, confusing value. So, what's the final verdict? In today's world of modern JavaScript, the advice from all the experts is simple. Start by using for everything. This is the safest choice and makes you think about which values in your program are truly meant to be constant. If you find that you have a variable whose value needs to change later on, like our cricket score example, then switch it to. And what about? Well, think of like an old black and white TV. It's good to know how it worked, and you might see it in old movies or old code bases, but for your new home, you'd definitely buy a modern LED TV, right? So stick with and for cleaner, safer, and more bug-free code. And that's a wrap. Keep laughing and keep coding.